Hey everyone, so if you're building anything in the cloud these days, chances are you're not just in one cloud, right? You're everywhere. And that creates this huge, complicated maze. The big question is, how do all your services, scattered all over the place, actually find each other to talk? Well, today, we're going to grab a map and navigate that multi-cloud maze together. All right, so you've put in the hours. Your app is beautifully distributed, it's resilient, it's spanning AWS, Azure, GCP, the whole shebang. But here's the real kicker, the million-dollar question. When one of your microservices over here needs to chat with another one way over there, can they actually find each other? It sounds so basic, doesn't it? But trust me, this is the exact problem that can bring your entire system crashing down. And if that connection just fails, boom. You've just run smack into a dead end in the multi-cloud maze. I mean, you're dealing with this crazy landscape of IP addresses that are always changing, different networking rules for each cloud. It's a mess. And without a clear path, your services just get lost. And when a service gets lost, that amazing distributed app you built, yeah, it breaks. Hard. So what's the solution? How do we actually draw a reliable map for this crazy maze? The answer, my friends, is a concept called service discovery. Just think of it like the big "You Are Here" sticker, or better yet, the destination pin on your Google Maps. It's the thing that tells every single service exactly where it needs to go. Okay, so what is it really? At its heart, service discovery is just the automated way services can find each other on a network. But the key word here, the really important one, is dynamically. We're not talking about some old, static paper map you fold up. No way. This is way more like a live GPS for your microservices. It's constantly updating in real time, telling you where everything is and, crucially, if it's even healthy. And you know what happens when that GPS goes down, right? The fallout is instant and it's painful. Imagine your front-end app tries to call the payment service, but your map, your discovery mechanism, is out of date. It has no idea where to go. So the connection just hangs, and then it times out. And what does your user see on their screen? A spinning wheel of death, a nasty error message, and poof, you just lost a sale. See? This isn't just some back-end nerdy infrastructure problem. It's a massive user experience problem. Okay, so yeah, the problem is very real. But hey, the good news is we're not the first people to walk this path. There are some really well-established ways through this maze. So let's take a look at the three main solutions. Think of them as three different kinds of maps you can use to guide your services. First up, you've got what I like to call the old highway. Yep, good old DNS. It's been around forever, it's pretty reliable, but let's be honest, it wasn't built for the crazy dynamic world we live in now. Then you have the cloud-native route, which is all about using dedicated service registries. And finally, we've got the smart grid, the service mesh, which is definitely the most powerful, cutting-edge option. So, how do these things actually stack up against each other? All right, time to get into the nitty-gritty. Let's put these three paths head-to-head and really dig into their strengths and, more importantly, their weaknesses, especially in a multi-cloud world. So this table really lays it all out, right? You've got DNS, super simple, it just maps a name to an IP address. The problem? Caching. It's just slow to react when an IP changes, and in the cloud, they change all the time. Then there's the registry, something like Console or Eureka. It's basically a central phone book for your services. They check in, clients look them up. But what's the big risk? Well, that phone book itself can go down, and suddenly nobody can find anyone. It's a single point of failure. And then the service mesh. This is the high-tech option. It uses these smart little sidecar proxies to handle all the traffic. It's incredibly powerful, but it's not free. It definitely adds another layer of complexity to your stack that you have to manage. Okay, to make this less abstract, let's walk through a super common example. Imagine you have a user profile service. It's running happily over in GCP. Now, it needs to check a user's login token. But the auth service, well, for whatever reason, that's running over in AWS. So how in the world does that little service in GCP find its way all the way across the internet to the right service in AWS and do it securely and without failing all the time? Let's zoom in on what I think is the most important factor here, resilience. Because, let's face it, in any distributed system, stuff is always breaking. With the registry, the client asks, hey, where's the auth service? It gets an IP address back, and then it just crosses its fingers and hopes it works. But what if that service instance just crashed a second ago? The client has no clue, it's flying blind. Now compare that to the service mesh. The little sidecar proxy intercepts that call, and it already knows which instances are healthy because it's constantly doing health checks. It's smart. It's not even going to bother sending traffic to an endpoint it knows is dead. So, let's walk through that service mesh flow step by step to see how cool this is. Step 1. Your user profile service makes a call to the auth service. Super simple, your app code doesn't need to know anything special. Step 2. The local sidecar proxy, which is running right there next to your app, just grabs that request out of the air. Step 3. The proxy looks at its own internal, always up-to-date list of healthy auth services, no matter what cloud they're in. And finally, Step 4. It intelligently sends the traffic to a healthy one. Maybe it picks the one that's closest, the one with the lowest latency. It just handles it, all automatically. Okay, so we've looked at the different paths, right? The old highway, the cloud-native route, and the super smart grid. The big question now is, which one is right for you? How do you actually pick the right guide to get you through your specific maze? And this is where we really move from the theoretical to the practical. Look, it's not about just grabbing the newest, shiniest technology out there. It's about taking a hard look at your application and asking, what do we truly need to be resilient? The real art here is finding that balance, not over-engineering your solution, but also not being naive about the failures that you know are just around the corner. So here's your final takeaway map, the cheat sheet for making this choice. If you've got simple, pretty static services that don't change much, honestly, DNS might be all you need. Don't overcomplicate it. If you're building modern, cloud-native apps, but they're mostly living inside a single cloud ecosystem, a service registry is a fantastic battle-tested choice. But if you are truly, deeply in the multi-cloud maze, and resilience is your #1 concern, then the service mesh is, without a doubt, your most powerful and reliable path forward. And that kind of brings us to one last really important thought. In any big company, the honest truth is you're probably not going to have just one of these. You'll have all 3 patterns running at the same time for different things. So the real challenge isn't about picking just one path. The real question is, how are you going to manage a future where your map is a messy combination of old highways, modern routes, and super smart grids? Getting all of that to work together seamlessly, well, that's the next level of the multi-cloud maze.